All right. Well, welcome to what was supposed to be the first talk on shifting testing left. So I'm going to give a little preface on what does shift testing left mean, and then I'm going to continue to talk a little bit more about unit testing. So the first thing is to understand that testing is infinite. And even if you don't believe it's infinite, it's obviously a very large space. There are tons of test categories that exist. And this is just a sample. And for each one of these categories, you could keep coming up with more and more and more test cases. But today, we're going to focus on mostly these first three. So what is an end-to-end test? You guys talked about this a lot last week, so I'm not going to cover it too much. But the thing to understand from the end-to-end test is that it's a complete end-to-end customer scenario from start to finish. So, simple thing might be, I'm a student, I go to the home page, I do a search for a session, and I browse to that session and at that exact moment, and then I close my web browser. It's as simple as that. But the point to understand from that is this touches a lot of different layers of the system. The front-end website, Solr, back-end DB, network, AWS, my client browser. There's a lot of opportunities for something that would cause inconsistent results. And so these multiple failure areas that could happen too also make it hard to root cause at the time that these failures happen, what was the cause, and root cause that quickly. So what is an integration test? The next one on the list. So this is kind of a conflated term. And the reason being is because traditional software testers tend to define this as the coverage between two or more modules. And the reason that's conflated is because a dev might define this as a test that I run after I do an integration, like a merge. This is starting to become more popular with continuous testing, and you would have a continuous integration test. This kind of is even more confusing for our organization because we have an integration team and they have their own set of integration tests. But this is the terminology that the industry is using, so I think we should probably use it as well and just know that we're all using the same terminologies when we're talking about things. So generally the first two things are kind of the same thing. After you merge is usually the first time you can actually test the integration of two components. And so that's why usually it requires some form of the system to be running. And so these can therefore run a little earlier in the development cycle than end-to-end tests can, but they can still be flaky because they tend to touch a number of areas and multiple components. So in traditional software testing, or traditional software development, test is near the end, basically once we're done. So considering we've learned testing is an infinite space, it's really kind of unfair to boil it all down to this step right at the end. And that's because as you go along this process, the change becomes more costly and tends to, if you're making change, it tends to mesh less with the original design. And so as you're moving along, you're building up risk over time. And bugs are found late, days before release, it delays releases, people's hair is on fire, and their work-life balance really sucks. And this obviously is not good for customers. So how do we fix this? So there's a cultural shift in software development testing that's happening, referred to as shifting testing to the left. And that's because you want to get tests involved early and earlier in this life cycle and at all stages. So what we're trying to do here by last week, the manual tests involving in bug bashes and bug smashes, is making sure we have everyone inserted in each one of these levels and putting their tester mindset on, their tester cap on, and acting as a tester so that we get a tester basically in each one of these stages. So how do we accomplish this though, and what benefits are we going to see? So first, there's a couple of shifting testing left mantras to talk about. And the first one is failing fast, which simply means that it's okay to make mistakes. And then second, that we make those mistakes early on in the process so that they don't become giant, huge gorillas in the room, problems later. The second part is limiting impact, and that simply means when we make mistakes, we don't affect as many people, and therefore it's less costly, it limits our risk, it makes it easier to roll back, or rolling back is simply built into the design or our process because that was thought of up front. Excuse me. And so together, these things create a cultural shift, making it safe. That's the important part, is safe to make mistakes, and therefore we can move forward faster and iterate faster, more cheaply and more easily. So for example, this is the onus of the automatic buddy builds. They fail fast because they run before the integration has occurred rather than later in the cycle. And second, they limit impact because, again, they run before integration has occurred. So potential problems hopefully only impact that person or that team and not anyone trying to, consume the build, the current release branch. But what else can we do specifically? And so there's some examples up here for potential future topics and things we're doing, but today we're gonna focus on implementing the test pyramid. And the reason being is because the tests at the top are late in the game. They're late in that software development cycle. And that makes them more costly, they're more slow, and we tend to push off the lower set of tests in this pyramid because upfront they appear to have a higher cost, but really with the later tests, we're just pushing off the maintenance and the investigation and that cost down to later. It also takes more people to get involved to investigate those, and so that's another reason why it's costly. So because they tend to be very flaky and costly to maintain, we end up losing trust in the tests that are higher in the pyramid. And that's bad because they become less valuable at that point. So we want to build the pyramid with equal levels of all these tests. I don't want to say that these higher level tests are not important. They're very important. We just want to have a balance. And that's important because you want some of these tests to be able to identify coverage gaps that you didn't identify lower in the pyramid. And so usually if you find a failure higher in this list in the pyramid, you're just identifying an area that you might need to unit test more. So just kind of pose a question to the room based on the types of tests we saw so far, and I specifically haven't mentioned or talked really about what is a unit test yet, but what do you guys kind of think? How are we balanced in this pyramid? Are kind of more top or middle or low heavy? What are your guys' thoughts? So that was integrations team saying they're pretty top heavy with the end-to-end probably Selenium tests. Yeah. So you made a really great point. That's what I was hoping someone would say. And that's because a lot of organizations end up with this, the inverted pyramid or the software ice cream cone. It's really easy to tip over. And we're probably, in like the C# world, I think probably more heavy in the middle. And so, we need to build up a bigger base and maybe trim off some of that flaky fat. So maybe it's good we didn't go to the Bainbridge ice cream trip. But so yeah, we definitely want to build up that bigger foundation, cutting or fixing flaky or long-running tests that could be tested at the lower level. So I know someone's going to probably ask, but Chris, I thought we have tons and tons of unit tests, and we have NUnit and tests written in NUnit. So what is, we don't have tons of unit tests, and so that's a case where things written in NUnit is just a framework, and even the end-to-end Selenium tests are written in NUnit. So what is a unit test then? So unit tests can run very early in the cycle, even before these merges, like at compile time. They do that by testing independent and isolated functions or methods. It means we don't need a test environment running, And that makes them not test all of these layers. The network isn't involved, the database isn't necessarily involved, although you can have database unit tests that we might want to explore. But that means that these are very deterministic and extremely fast. And so we can start to shift left by creating more of these, and I think most importantly by running them automatically as part of dev local builds. And I'll give a little bit of an example in my demo later of what that could look like. But for example, JavaScript, Gulp, AntWatch, they can even inform you of unit tests or like linting failures simply when I save a file. So I'm like told about the problem that I created immediately. And that really limits impact. And like I don't think you can fail faster than when you click save on a file. So some professional solutions exist in .NET, but they're fairly expensive and they only work in Visual Studio, and we have the problem of people work in different environments and different stacks. But we do have an option that I discovered that's .NET Test. It's part of the .NET Core framework, SDK, and we can use it to do a watcher. And again, I'll give a little demo of what that might look like. So that's food for thought, but now that we kind of know what a unit test is, let's see a real definitive example. So here we have our method under test. This is a calculator class that might have a function of a base to the power of an exponent. I found this on Stack Overflow, and I thought it was really interesting because I probably wouldn't have written the method this way, and therefore that's why I want to write some unit tests for it, because let's imagine I'm refactoring to this method because I found this method and they're saying it's more efficient. So you want to start with your kind of like golden path, what we were talking about before, you know, the happy path. And so an example might be 2 to the power of 3 equals 8. And we tend to name a good naming convention for the test names. This will start with the method you're testing, the inputs you're providing to it, and your expectation. And you want to use something called a range act assert. And simply what that means is you're arranging your setup of your test, instantiating your class that you're going to test, acting by calling your class under test, and then asserting the expectation. So we've got this example of, this is just one unit test, but can anybody come up with, you know, what are some other, you know, this is the golden path 2 to the power of 3. What are some other inputs I might want to test for this?
Negative numbers, 0 to 1.
Any others? Maybe some nulls. I don't know that it matters so much though, because we define the type as not nullable in C#. Big numbers? Awesome. So here's a couple examples that I came up with before. I think it's pretty much the same list you guys came up with, but if you try the last 3, this would fail. So, however, we usually test a much more complex class than this and methods. This is a really simple thing. You know, what if we imagined the calculator is actually an accounting object that takes in invoices that get populated by data in a database? How do we deal with that logic, and how do we go with the unit testing mantra of being isolated and independent? Well, we can do that with faking and mocking and stubbing. Oh my! So often referred to as mocking, stubbing is simply creating a test version of your dependency that returns deterministic results, rather than, for example, going to the data layer and crossing the network and touching the database. And what mocking is, it's simply verifying that interaction has happened, but the expectation of an interaction has happened between 2 different modules. And that's usually done by tracking the stubbed calls that you're making. Both generally require implementing an interface pattern, but these can easily be done without a framework. You don't need NUnit, you don't need a mocking framework. However, especially in .NET, we can have issues when we're using statics or sealed classes or private functions. So keep that in mind. Faking, on the other hand, can get around some of those cons. But the problem with faking is it generally can allow for a bad design. And Microsoft, even on their website, suggests against using faking unless you absolutely need to for something like legacy code that you're not going to go touch ever again. And we can't use faking because it's in Visual Studio Enterprise. But yeah, Microsoft actually suggests you use their stubbing. They don't provide mocking, their stubbing framework, which is part of MS Test. But by far, mock, or also pronounced mock-u, is the most used framework. It's got about over 30 million downloads. The rest of these other frameworks that I've kind of pointed out here and did a little research on are like less than 3 million at best.
So, Rhinomox has been dead for like 5 years.
Yeah, there you go. You don't even want to use that one. Just for the people on the webcast, that was a comment. Rhinomox has been dead for about 5 years. And a lot of them use bad patterns like accessing methods via string names, which kind of defeats the point of being able to do refactoring. So, on to the demo. What does this really look like? Let me bring this up really fast. So the other thing to note is I put this in a repository online. The link was in the slide, so if you're interested in playing with this or taking a look at it, check out the test examples repository, I think is what it was called. So first, the calculator class and calculator tests are also in this, if you want to take a look at those. But we're going to take a look at the slightly more complex one that implements some stubbing. So I have a demo class here, which simply is maybe an API or a touch point for the UI to be able to, say, change a user's password. So you can see in here, sorry, this is really large. Here's the kind of the meat of the method, calls change password. It checks a number of different things, like it's a minimum length. It checks that you have at least 2 of a lowercase, a number, or a special character. It checks that you haven't used one of your last 5 passwords, and then kind of reports out success and the state of that. So how would we go about testing this? So here is the test class for this. And you can see I have a number of different test cases written, and this is a great example of, if you haven't seen it before, parameterized test cases in NUnit. So I can have one test method and pass in a number of different inputs and assert an expected result on each of them. And so the first one, we start with our happy path, or we're calling the golden path, is the good password. It's got the length, it's got a capital, it's got special character, and we go through it and we verify that. But the interesting thing is this is not actually touching data in the database. I've stubbed out a class, a test class here at the bottom, mock panopto db data context, so that I can return deterministic results for those tests and not get intermittent results, or make sure I have to do database setup, or if someone else is touching the database at the same time, for example. And so one of the examples is, remember that check I was saying it can't match one of the last 5 password histories. So instead of actually going out and reaching out to the database, I just return a stubbed value that, hey, if my password check matches this history password, go ahead and return true. So that's the example of stubbing. And then the example of mocking is here. There's a submit changes method on the panopto db data context, and I want to verify that that was actually called. That's the interaction between the components. That's the part that I want to assert on as well. And so that's really all it is. It's this test class down here, and I find this a little bit easier to understand than some mocking frameworks, because you really have to know that mocking framework. This is just another class and that's really easy for us to all understand. But you could have done it this way. Did I change the file somehow? There we go. We could have done it this way using the mock framework. And so instead of writing a test class, they've called these setup methods here, or I've called setup methods here to set what I wanted to return when I called password history matches with the parameters of any string or any integer I want to return false. The order of these really matters because they take over logic from the previous one, so that can kind of get confusing. But that's really all it is. These 4 calls here are what replaces my test mock panoptodb context down here. The other thing is when you want to actually test a mock is you call this verify method, and that's, again, testing that same submit changes method. So that's kind of an example, and we can even run all the tests here, and they run pretty fast. So there we go. And there's those 3 calculator tests that I showed would fail. So, and again, obviously this required me thinking about refactoring out my panoptodb context. So here's my panoptodb context where I had to create an interface in front of it so that I could actually pass in these mock objects instead of the real database. So the other thing I talked about was we want to be able to run these like with a gulp watcher or type of thing. And there's dotnet watch. So let me switch to our, yep, and hopefully, yep, build finished. Sweet. So I started this command file, just a batch file, that's just got some little things in there to make this work. But so it's just sitting there waiting, and if I go back to my Selenium web test project, for example, and delete this line so that I can do another build, it starts building, and we watch our watcher here. So it looks like it's still building the project in the background. But this is set to, what it's doing is it's watching for built files, DLLs, to be changed. And then it kicks off the watcher, which runs all the tests. This isn't actually running all the tests, it's just an example of if we had like 5,000 unit tests that each ran in a few milliseconds each, this is what it would look like. Instead, this is just displaying out what tests would be ran because obviously our tests run for hours. But there, it's done. So anytime I build, it's just in the background or in my other screen, I'm getting an immediate feedback that I broke something or not. So that's the end of the demo. I definitely encourage more questions. If you're interested in sticking around, doing more discussion, I definitely want to encourage that. But yeah, just remember kind of like the top level things of this were, you know, try to build out your testing in a pyramid. We need to build absolutely more unit tests as we're building new features. Try to think about ways that you can run those automatically. Make sure you're keeping them short. So yeah, those are kind of things. Fail fast, you know, make failing and mistakes, you know, safe. I think that's really important to us to be able to move fast and keep up. All right, thanks.